Hi everyone, hope you're doing wonderful. Welcome to the Early Career Podcast. This is Priyanka Mahankali, your host and friend, and we are at episode 3. Apologies for the delay. This was supposed to be done last week, but because this is a brand new podcast, there's some editing and things like that I'm still learning as I'm helping you guys. So thank you for your patience. And so this episode um, is actually about AI. And the reason I started with the first tech topic to be about AI is it's obvious, right? Everyone's talking about it, and it's not just talk anymore. It's not just hype. It's actually reality. Lots of industries, almost every industry, is looking at reinventing their business visions and their goals to incorporate AI as part of their productivity. So productivity within their company to actually have employees use AI for a variety of purposes to accelerate different aspects of the company. We call that internal productivity. So, along with that, also external productivity. So, how can a business actually um, make use of AI to make to help their consumers or their customers make better, quicker decisions, and so on and so forth. For example, you will see that if you are trying to book a flight, now you will be most likely talking to a virtual AI assistant, which is no longer hard coded. Like the question and answers are not static anymore. They're very dynamic in the sense that because it's AI driven or AI powered, it can handle any type of question that you may pose, virtually any type of question, and should be able to get a resolution. Um, and also keeping in mind the context of each question, right? Because one question may be about some delay that happened a few days back, and you want some refund from it. But another question can just be something as generic as, I want to book a flight, or I want to cancel this flight from this trip. So there can be a variety of questions ranging from very simple to very complex and nuanced and edge cases. And so because AI is just so powerful, it's able to now handle a massive amount of questions, different kinds of questions, different levels of complexities. And so that's just one example of the power of AI and why every industry is looking at it. And that's why now it's more than important for every individual, regardless of whether you are in a tech role or in a non-tech role, fundamental understanding of what is this AI, how to use AI, and then having that knowledge to understand or to make change within your own organizations is just really, really important right now. It can set you apart from everybody else. And in fact, it's going to become the new normal, where in the next 1 year, actually less than 1 year, everyone's going to be expected to know some, AI in some shape or form, either at a deeply technical level, or at a foundational higher level where, for example, if you're in tech sales and you're like an account manager, so you're trying to sell AI, so generative AI specifically to companies. So then you should know something fundamental, something basic before you engage a technical specialist or resource within the company. And so upskilling on AI is very, very important. So that's why I decided to cover this topic. And as we cover um, topics within AI, we will also bring guests and specialists who will actually shed more light on their experience of building things using AI, what kinds of use cases and things like that. So exciting times are coming. So let's start with the history. And the history of AI is very important because we don't sometimes we think that we just need to know the current technology and just what is happening right now. But my opinion is that it's always very important to look back and think about why this technology or why this certain thing even existed in the first place. What did it come from? Was there a problem that the world was trying to solve, and then this technology became the solution to that problem? Because that gives you an understanding of why. Like why was AI created? What was the foundational founding ideas that led to its creation, and then why did it become so big? And it's important then to journey back to really understand the history first. So let's get started. So in the 1940s and 1950s, which was called the Age of Imagination, there was a British mathematician called Alan Turing who actually posed a question, and the question was, can machines think? And this was the time before the internet. So at that time, it still felt like a very fictional question, but it was a valid question. If machines can think and perform tasks as intelligently as humans can do. And so from that came what was called the Turing test, where if the Turing test was that if a machine, sorry, if a human being cannot tell if they're talking to another human or a machine, then that means that the machine could be considered as intelligent. Does that make sense? So, how do you know something is intelligent? Is if you don't know if you're talking to a machine or a human being on the other end, right? Which makes sense. And that's how you can consider then or deem a machine to be intelligent. And that was called the Turing test. And so, while this was fiction, it planted the seeds for modern day, what we call as artificial intelligence or AI. So then in 1956, which was called the founding era or the birth of AI, a group of researchers, of course, it had to start from a university. So a group of researchers came together for a summer research project where they believed collectively that they could precisely describe human intelligence to a machine and then have the machine simulate that human intelligence. And so that marked the official birth of the term artificial intelligence as we know it today. But unfortunately, at that time, computers were slow and memory was very limited. And of course, because it's limited, then it's expensive. And the fact that the real world was far more messier and complex than the scientists had initially imagined. So, translating that level of complexity into a machine can be very challenging because, if you are expecting a machine to be truly intelligent, meaning that it passes the Turing test, where you can't really, sorry, you can't really tell if it was a machine or a human being that you're talking to. That means that implies that that machine then has to understand all kinds of edge cases and nuances and complex contexts that human beings can very easily and naturally understand, right? Like if you see a tree, you know that's a tree, even if that tree has like, red colored leaves, you still know that that's a tree, right? And so even something like that, and having a machine, programming a machine to recognize something like a tree, regardless of how it looks and how it changes color and things like that, it's very easy for us as human beings to interpret something as a tree because human intelligence comes natural to us, of course, because we are human, but it doesn't come naturally to a machine because it's a machine. So how do we take human intelligence and translate those elements of human intelligence into a machine while with the limited memory and compute and all of that, right? So that was very hard at that time. And so in the 1970s to the 1990s, which was called the AI winters, and as the name suggests, it was not the fun exciting winter, it was the time when all this research, while it was ongoing, it also reached a point where governments and investors weren't actually able to believe in the concept of artificial intelligence because obviously because there weren't enough resources to actually for the scientists to actually prove it. If you don't have enough compute, how what are you going to uh, train the system with, right? And how are you going to bring all these thousands and billions of parameters into this machine to then have it simulate human intelligence, right? And so that led to investor funding drying up, and general research slowing down. But of course, research didn't fully stop, since researchers, of course, they were passionate, they were enthusiastic, and they kept going even with limited trust in, or limited belief that AI is actually going to be a real thing in the future, which at that time it was still not. And during that same time, something called rule based systems emerged, which then mimicked human decision making. But it was generally expensive and brittle. So, if you're trying to come up with rule based systems, then of course they are going to be limited in what they can achieve, because human intelligence, um, you can think of it as this vast universe, right? And there's just so many aspects to our intelligence that you can't really box in like a rule or a set of rules. But rule based intelligence, or rule based systems came as a sort of intermediate, emergent system to mimic human decision making. But of course, it wasn't a hit. It didn't go very far because it was expensive, since it's rule based. So you have to like literally code every single, you know, task and every single sort of context and behavior into it. And then of course, because of that, it was also brittle, because it had certain limitations, and it would then break beyond, if you ask it something that it's not able to handle, which is very much possible because it's founded from a fundamental limitation of rules. So that was the time when AI went quiet, sort of. And as you can see, it was because of a variety of factors: societal acceptance, compute, so technology like the internet, data, compute, memory. Those were things that were not easily and readily available. Um, Things like that, and is why AI went quiet. But then in the 1990s to the 2010s came the era of data and the internet, and having algorithms that then came. So, because of the availability now of the compute resources, and the internet and algorithms that then could be trained on this vast amount of data that was accessible through the internet, AI the research around AI reawakened, and progress, you could see some tangible progress. Then in 2010 came machine learning, around that time, where machine learning was able to outperform rule based systems. If you remember, we just talked about rule based systems where they were, kind of hard coded, so then they were expensive and brittle. So machine learning emerged, and machine learning algorithms were able to outperform rule based systems by being able to learn from past data and finding patterns from past data to then predict future outcomes or predict future um, aspects of things. And so prediction models developed, which we call as machine learning, which is used to look at past patterns to predict something in the future. Then in 2012 came deep learning. So, deep learning is another term which is actually based on the concept of neural networks. So, neural networks is the way our brain fundamentally functions. Um, Neural networks are how the neurons in our brain are interconnected to another to then take an input, process it, and then arrive at a certain output. So that's what neural networks, I mean, it can get very deep. So if you are interested, we can do another deep dive. There are also so many videos on YouTube, and I know there's so many amazing people out there who've explained it really well. So just tap neural networks on YouTube, and you'll find a lot of videos there. So in 2012 came deep learning, which was neural based on neural networks, and that was a huge hit. And at the same time, voice assistants like Alexa, Siri, and Google Assistant bought brought AI into the hands of the consumer, the everyday person, making AI accessible and actually more real, because people started seeing at a broader global level the value of AI and how it can really change lives, and how you can actually use voice to recognize people and then take actions, personalize actions based on that. Also, how you can use voice to generate commands and make the device perform tasks for you, actions and things like that. So it started to become very powerful in our everyday lives at that point. So then now we come to 2020s, which is actually our current time, which we call as the rise of AI, or the rise of generative AI in particular, where machines could not only now predict, like machine learning, but they could also create. So machines were not only smart, they could also imagine new things and create things that didn't actually exist before in the form of data, whether that's text or images or video or really any content. So as I said, machine learning would you would need a specific kind of algorithm that you would choose for a prediction algorithm. You have a specific data set that you need to use to train this algorithm or this model, and then use that trained model to then run it through a new data set to then get a specific prediction, which is again very use case specific. So if you're trying to do something like fraud detection, then for fraud detection there are certain kinds of algorithms, there are certain kinds of data sets that you need, and then that's how you make a prediction for fraud maybe. But for the difference with with generative AI is that they work on a concept called large language models, or LLMs. And you might have heard of it. If you have not, make sure that you write this down and look it up. So these are some terminologies that I wanted to expose you to, along with sharing the history, because you might not know where to start from, right? And this is a good start. So if you know the history, you kind of know, okay, fine, I can start from some of these fundamental concepts. And it's very important for you to know the fundamentals, because I don't want you to be someone who knows the deeper stuff and not know something very fundamental like the basics. So anyway, coming back to generative AI, it is based on a concept called large language models, which again is fundamentally from the deep learning concept called neural networks. And so large language models are trained on a universe of data, and by that I mean you can imagine like literally the full internet of data. So it's trained on such large amounts of data that you don't have to choose a specific LLM for a specific type of use case. I mean, yeah, there are definitely now the companies are coming up with different types of LLMs for different types of inputs and different types of outputs. But in general, largely, a large language model should be able to input take an input and then produce an output, and that output is not just a prediction, but it can be generating like a storybook, or generating marketing material, or generating like an itinerary. So something that even didn't exist before, like for example, let's say that you're going from um, New Jersey to Mumbai, and so you want to and you have only like 5 days in India, in Mumbai. So you're telling it, okay, I have these dietary restrictions. This is what my immunity looks like. These are things I'm not good with handling spicy food, but I also want to see some of the historic places in Mumbai, etc., etc. So and I have maybe 2 kids, and you know, this is where we are going to be staying, and so from this, so it's able to, because it's trained on a universe of data, is what I call it. It's able to understand what you're saying, what you're asking of it, and actually give something that is very customized to your question, to your need, which it was probably never asked before. But that's the power of AI, that it's able to create new pieces of information from existing pieces of data that it already has been fed with and it has been trained on. And so you might be wondering that, we talked about like AI, machine learning, deep learning, and then generative AI. Are these all similar? Because, sometimes AI and machine learning are used interchangeably, right? But really, the way it works is AI is, think of artificial intelligence as this large umbrella where it's about creating, having machines and creating systems that simulate human intelligence. So think of it like a framework or a mental model. So AI is like a concept at large, and then within AI you have machine learning, which is a subset of or a subcomponent of this large AI universe, which does something very specific, such as prediction. And then within machine learning, you have what we call as deep learning, which is again a subset of machine learning, which uses neural networks. And then lastly, we have generative AI, which is a subset of deep learning. So it's like a hierarchy of things. And that's how you would look at it as, and that's how you know what is where, like what is machine learning, what is AI, what is generative AI, what is deep learning, and that they're not similar, they're not the same, but they're like a subset in a certain hierarchy. With that, hopefully you have some initial information, history, and I wanted to share this history because, if you think about it, like it also gives you a sense for how do you like how do you view technology in general, and how do you view evolution of something, um, because now you have something called SLM, or small language models, which is something researchers and scientists are looking at and AI specialists are looking at to see how you can actually save energy, compute costs, um, energy from a sustainability perspective, power, and all of that, to actually come up with the same level of accuracy in terms of output, if not more, from a language model that is smaller, which is called SLM, or small language models, as opposed to LLM, or large language models. So coming up with a SLM to accurately or even do the task better than a certain LLM, or large language model, is something that is actively being researched, and actually there are some proven theories as well around it. But you see, like even after we have come up with generative AI and the success of large language models and what it can actually do, and it going from like a myth 2 years back to a reality, like a full blown reality here 2 years later, there's still evolution. And now we're going to like an optimization phase where we're trying to, and the next 2 years is going to be all about enhancing productivity overall, but also optimizing the use of compute, and power and all of that. Because at some point you can't just keep using the kind of compute that is required for running and training these large language models, right? So so that's where we are at. And having a sense of history will actually give you a sense of how do you think about it in the future, what kinds of parallel technology advancements are happening that will influence or shape AI, or even really anything that you're working on. And that's business strategy 101 right there. Because if you look at it, we talked about how it started off with the concept, and then there was some sort of initial proven theories, and but then because computing resources were limited, they couldn't kind of go ahead with it. But then eventually, when the internet became a thing, then AI also started becoming a thing, because there was more data, there was more compute, there was more advancements in just infrastructure in general. And then as these technologies improved, GPUs, compute, then AI also became more and more real. So, like, it gives you a sense of, at a strategic level, what are some of the parallel technologies that influenced the growth of AI. And that's the same thing that I was able to do for as a strategic lead for commercial aviation. One of the big focus areas that I had was connected aircraft, where I was looking at what are the some of the parallel technology advancements in satellite and connectivity, to then see what advancements we would have in the passenger and entertainment space on board, as well as fleet telemetry gathering at fleet scale and things like that. So, connected aircraft is a concept where you are able to um, exchange data between the aircraft and the ground, send data and then bring data back as well. And from that, we can drive a variety of different use cases, such as passenger personalization on board. For example, your seat back or your entertainment unit that you have right now, you might have noticed that it is generic, but it could be more customized and more personalized, similar to your living room experience that you have with your Netflix and other OTT platforms, where it knows exactly what you like and it has created a persona of you, right? And because of that, it knows exactly what you like and what to recommend next, and it saves you time and also makes you feel like you have a very personalized experience with that platform. And so that's what they're trying to create on board as well. And so I was looking at it from a strategic perspective to kind of plan ahead and create a vision ahead by thinking through what are the parallel technology advancements that are happening, for example, with low earth orbit satellites. And I was looking at that and thinking, okay, if this is advancing, then these sort of use cases are things we can start with first, and then we can start with non-critical use cases, and then we'll see, depending on how coverage increases or improves with satellite connectivity, we can go to more critical cases. And I'm just oversimplifying this, of course, just for the sake of this conversation, but you see how knowing about the history of something can then put you in a strategic mindset of looking at it from a evolutionary in an evolutionary way, where you look at other things that are also happening that can influence the progress, the success, or the downfall or failure of different things over time. And so with that, thank you so much for listening. Hopefully the history session was valuable, and now you can feel more confident that okay, you know where this has come from, so you can predict where it is going and where it's headed. And we will actually be having, for our next episode of on AI, we'll actually be having a guest speaker uh, who is an AI specialist on all the things that we discussed. So I'm very excited to bring that person on board to share with you some insights and also give you um, some use cases, and also some things that you can work on, like school projects. So yeah, very happy to have this person join us in our next session. Until then, take care, have a wonderful rest of your week, and stay healthy, stay passionate, and stay brave. You got this, right? Bye. Take care.